Welcome back to Insight Study by Ritik. So today we are going to solve majority element 2. It is a medium problem, but the solution is easy. So let's see the problem statement. Given an integer array of size n, we are given an array of size n and we need to find all the elements that appears more than n by 3 times. That is, n is the size of the array and we need to find all elements that appear more than n by 3 times. Check our examples. Like it is given 3, 2 and 3. So number of elements n equal to 3 and n by 3 is 1. So we need to find all the elements that appears more than once. So 3 appears twice and 2 appears once. So which element appears more than once? It is 3. So we need to just output this element, which means all the elements that appear more than n by 3 times. So how can we solve this? We can simply use hashing, like counting the elements, like 3 is appearing twice and 2 is appearing once. We need to count what is the frequency of each element. So how can we do hashing? We can simply use maps. So we will have a map of int comma int. Map is what? Map is a key value pair. Means we will insert all the elements and do the hashing. Nums of I will do this. So we will count if all elements in the map are crossing our limit or not. So for auto, we will use for each loop. Let's say m in map, our map mp. We will check that for each element, this second is greater than our given frequency limit or not. We'll check this, and if it is true, then we will answer dot pushback. So simply we will have an vector of answer, vector of int, and we will push back the answers, and through this we can solve the problem. It is our first approach, but here we are using map. So map will cost us of n log n time complexity and also big of n space complexity. Let's check our second method. You can short it and then count. If you are not comfortable with maps and all, then we can go through this. First we will sort our array given, that is nums. After sorting, we will just walk through the array, that is we will check from I equal to 0 to n. We will check if have a temp, we will have a temp that is sent. We can fix it with int max to avoid collision. So we will check if temp is equal nums of I. For every element we will check. If it is equal, then we will increase our count, and if it is not, then what can we do? If it is not equal, then means we have our count and we should check how many times it occurred. We'll check if our count is greater than frequency limit. If it is true, then we will push back our array answer dot push back into our array. What we will push back? We will push back the temp, because we have stored the temp, and the count for temp is what we are checking. So if it exceeds the frequency limit, means it has appeared more than n by 3 times. So we will store in our answer vector, that is temp, and then we will again update our temp with the new element, because we have encountered a new element here. And at last we will also update our count to 1. We need to also have a check outside the for loop, because if for the last element, if it occurs that it is equal to temp and it increases the count, then we will skip this pushback because it is in else. So we need to check once outside the loop. If count is greater than frequency limit, simply we will copy this answer dot pushback temp, and at last we will return our answer. Earlier also we will return our answer here. So we have seen this was our n log n time complexity and n space complexity. What is this? Because of sorting, there will be n log n time complexity, and space complexity is, we have not used any space complexity, it is big O of 1. So let's solve the follow-up part of our question. What is the follow-up? We have time complexity of big O of n, linear time complexity, and space complexity is big O of 1. We have a standard algorithm for this. Algorithm, that is Boyer-Moore. So let's see our problem once again thoroughly. We are asked to find more than n by 3, the elements that appear more than n by 3 times. Okay, so how many elements can appear more than n by 3 times? Let's check. Total elements n. Let's say one element appears more than n by 3, that is n by 3 plus 1 times. Okay, so how many more elements are left? Twice n by 3 minus 1. Okay, so if another element appears more than n by 3 times, that is again we will minus n by 3 plus 1. So how much will be that? N by 3 minus 2. Can we have any more elements that will appear more than n by 3 times? No. Let's see. This is our array of n size. We will divide it into 3 parts. Okay, this is n by 3, this is n by 3, this is n by 3. If we take more than n by 3 from this, and we will take more than n by 3 for this, then we will be left with obviously less than n by 3. So we can only have two values for which this problem statement actually have a solution. Okay, we can't have more than two values. We saw it now, right now. And we can also have similar questions like find all the elements with more than n by 4 elements, more than n by 4 frequency. So if we have more than n by 4 frequency, then how many elements will be there? 3 elements simply. And let's say if the question is for n by 2, so now let's see the Boyer-Moore algorithm. We will have candidate and count. So how many candidate and count? We will have two candidates and two counts. Candidate 1, candidate 2, and count 1, count 2. Okay. What we will do? We will just see in our array which two elements are our candidates that will satisfy, that may satisfy actually, the elements that may satisfy our solution. We will check for the elements that will appear the most times. How will we check? We will traverse through the whole loop, whole array. We will traverse through the whole array and we will check if the given element is equal to our candidate 1. Is it? If it is equal to our candidate 1, we will increase our count of candidate 1. Else if it is equal to our second candidate, okay, then we will increase the count for second candidate. Else what can happen? Else if that is it is not equal to our candidate 1, not equal to our candidate 2, then else if we have count for candidate 1 equal to 0, then what we'll do? We will simply say candidate 1, you replace yourself with the present element. Okay. Else if our count 2 is 0, then we will replace candidate. We will also replace here count of 1 is 1. Okay. If this is also false, then we will go there. If count of 2 is equal to 0, then we will say that count of 2, you replace yourself with the present element, and we will update the count of 2 equal 1. Else if all the statements are false, then what can happen? That means we have an element that appears once, and now our candidates are not equal to that element. Also our candidates are not 0, candidate count are not 0, then we will just decrease the count. We will just decrease the count of both our candidates. In candidate 1, we will have one of the elements that is appearing in top 2. Okay, in candidate 2, similarly we will have an element in top 2. Now we know that these two elements are in top 2, but we have a condition that the top 2 elements also should be greater than our frequency limit. What is our frequency limit? That it should be more than n by 3 times. Okay, so for this we will again traverse array. We'll traverse the whole array and we will just check if the element is equal candidate 1, then we will simply increase our count. We will have to count 1 equal to 0 and count 2 equal to 0. We will increase our count 1, else if nums is equal to candidate 2, then we just need to increase the candidate 2 count. Okay, so now we have the counts of candidate 1 and 2, and we know that they are top 2 elements. We also have their counts. Now we need to check our condition that if our candidate 1 is greater than frequency limit. If it is, then we will push it to our answer. Again we will check if count of 2 is greater than frequency limit. We will also push it to our answer array. That's all, and at last we will return our answer array. That's the solution. So let's start with our first solution. First we will solve it with hashing using maps. So let's start. Let's define n as our dot size, and let's also define our limit, that is, what is our frequency limit? N by 3. That is what we need to check for our problem. Now let's also define a map of what? Int and int. Now we need to store the frequency in our map. We will traverse through the array given and store the frequency as we said. So we will store as frequency of nums of I, that is frequency of that element. We'll do just plus plus. Simple. And now we just need a vector for our answer, int vector. Let's name it. Now we will traverse through the map and check if the frequency of that element is greater than our frequency limit or not. And if it is greater, then we will just push back into our answer array. If the frequency, that is f dot second. Why f dot second? F dot first stores the element and f dot second stores our count greater than frequency limit. Finally we will return our answer. Okay, let's submit. can, let's remove this and do sorting of our nums. We'll traverse through the for loop and we will count if the number is more than frequency limit or not. So let's define a count also. Count is 0 and let's have a temp variable. Let's define it to int max, as I said, to avoid collision. Okay. Now what we'll do, if our given element, that is we are storing in that, if temp is equal to the current element, then we will just increment our count. Okay, and in else we will check if the count is greater than our frequency limit. If it is greater, then what we will do, we will push back it to the answer. Push back what? Push back 10. Okay, and we will change our temp to the present element. And also update our count to 1. This is what we will do, and I also told you that to check for the last one we will have to do it outside also. So I am just copy pasting it. Done. Let's submit. See, our solution is correct. Let's go to the last solution. Define our candidates. Candidate. Let's check it. Candidate 1 and count. We need to define two counts here. Count 1 equal to 0 and count 2 that is also equal to 0. Now the main part of our Boer-Moore solution, that is we will traverse through the array and we will check what are our two candidates, that is our top two elements. So let's traverse through the array. Now we will check if it is our candidate or not. Candidate equal to current element. If it is, then we will just increase our count of candidate 1. Else, if it is our candidate 2, it was candidate 1 and it is candidate 2 equal to nums of I, then we will increase the count of candidate 2. Else, if both the candidates are not the current element, then we will just check if our count for the first element is 0. If it is 0, then we will update our candidate to nums of I, that is our current element, and increase the count to 1. Similarly, we will also check for if count is 2, then we will do update our candidate 2 nums of I, that is our current element, and update the count of 2 1. Now if all these are wrong, then what we'll do, we'll just decrement our counts. Now we have our top 2 elements, so just we need to count the frequency of our top 2 elements. So we will again traverse through the whole array. This time we will just store the counts. Okay, let's update our count here. Count of 1 equal to 0 and count of 2 also equals 0. If the present element is equal to our candidate 1, then increase count of 1, else if it is equal to our candidate 2, then we will increase count of 2, else we will do nothing. Now just check for our actual case that it is greater than our frequency limit or not. If count of 1 is greater than frequency limit, then we will push back count of, that is candidate 1. We are not using else here because we need both the elements if possible. This is our optimal solution, that is it uses just O of n time complexity and O of 1 space complexity. Thank you for watching. Please like, subscribe.